So we'll discuss CET questions. Yeah. So ray optics part. It starts from 21st. So what is the question? Given figures show the arrangements of two lenses. The radio of curvature. So all the curves of this are same. The ratio of the equivalent focal length of combinations P, Q, R is. So in all the three, they are same lenses, only plano convex lenses. So effective focal length is 1 by f is equal to 1 by f1 plus 1 by f2. So if you see f1 or f2, both are identical only. This part or this part, both are identical only. So 1 by f is equal to mu 2 minus 1 into 1 by r1 minus 1 by r2. You take plane first, then convex next, or convex first, then plane. For both the cases, you will get same f, because here r1 will be infinity, r2 will be minus r. Here r1 will be plus r, r2 will be infinity. So you will get 1 by r only. So f is same always. So 1 by f will be 2 by focal length of each lens. So the ratio will be 1:1:1. Second question. Area of light passes through an equilateral prism such that angle of incidence is equal to angle of emergence, and the latter is equal to 3/4 of the angle of prism. The angle of deviation is. So I is equal to E. It means it is minimum deviation condition. And they are given E. I is equal to E is equal to 3/4 of angle of prism. Angle of deviation they are asking. So we know sin I by sin R is equal to N2 by N1. So I is 3/4. Okay. And R is sin A by 2 is equal to, oh, sorry. One minimum deviation value. Deviation value is 2i minus A. And A is 60 degree because it is equilateral prism. So A is 60 degree. So if A is 60 degree, then this is 3/4 into 60. That is 1 the 15 the 15 3 the 45. So 45 into 2 is 90. 90 minus 60. So deviation is 30. Then we have next question. This theoretical question. Spherical aberration in lens. So it is C option. It is minimum when total deviation is equally distributed over the two surfaces. So if deviation is uh, not equally distributed, then there will be some aberration, some defect in the image. But if it is equally distributed, then aberration will be very less. Basically, aberration means some distortion. Now we have 24th question. Is an astronomical telescope has an angular magnification of magnitude 5 for distant objects. So magnification is how much? 5. The separation between the objective and eyepiece is 36. So magnification is FO by FE, and separation is FO plus FE. This 36 centimeter. Final image is formed at infinity. So this will be FE. The focal length FO of the okay, FO and FE you have to find. So FO is equal to 5 FE. So that if you substitute here, you will get 6 FE is equal to 36. So FE is 6. So FO is 30. 36 minus 6. So it is option D. Then we come to next question. And fifth question. Identify the wrong description of the below figures. So these are the figures. It's far-sightedness and short-sighted. So far-sightedness means they can see far things, but they cannot see very near things. And short-sightedness means they can see nearby things, but they cannot see far things. So in it is called as myopia and hypermetropia also. So in short-sightedness or myopia, what happens? This is your eye. This is your eye, and this is the eye lens. The image will not be formed at the retina, but it will be formed here. That is myopia or short-sightedness. Short-sightedness. So it forms here only. So this is myopia actually. And to have correction, what we can do? Can use a concave lens. Then it will diverge the rays little bit so that it can form image here. Basically, eyeball will be little larger, or cornea is very spherical, so that's why it bends too much, so that it will not be focused here. And hypermetropia is the image will be formed behind the retina. So here we have to use convex lens so that the rays coming are converged, so that they will be converged here. So if you see in this question, they have asked which is wrong. So it can be either this or this, because one represents farsightedness, three represents far. So either one or three should represent farsightedness, correct? So if you see third option is farsightedness. But A option, if you see, A is for myopia actually, correct? So this is the wrong option, wrong distribution, wrong description. So it is option A. Even if you don't know, logically also you can solve how. See, 4 is correction for farsightedness. These two are correct for sure, huh? Other, because answer can be either of these, one or three, means A or C. These two are correct. So 4 is correction for farsightedness. The fourth one is correction for farsightedness. So it means we are using here convex lens. It means we are converging it so that the image will form little uh, little to the towards the islands, right? So it means in farsightedness the image will be formed here, and you use convex lens to correct it to have here. So this is correct description of farsightedness. Third diagram. So third is correct. So A should be the answer. Like that also you can do. Then we have 76th problem for compound microscope. FO is 1 centimeter, FE is 2.5 centimeter, and object is placed at distance 1.2 centimeter from object lens. What should be the length of microscope for normal adjustment? So what should be the length for normal adjustment? Means final image is at infinity. So this is a microscope and final image is at infinity. It means this is at focus of eye lens. So this is length of the microscope they have asked. So it will be Fe plus this image distance for objective. And what is the image distance for objective? F is 2.5. 1 by lens formula we can use 1 by F. For objective, focal length is 1, and this we want, and object distance is 1.2 centimeter. So minus 1.2 centimeter plus 1.2. 1.2, if you see, it is 10 by 12, which is 5 by 6. So 1 by V naught is equal to 1 minus 5 by 6, that is 1 by 6. So this is 6, that is 6 centimeter plus this is 2.5 centimeter Fe. So VO plus Fe is length of microscope, it is 8.5. It is not tube length of microscope, it is length of the microscope. So from objective to eyepiece, how much is the length? Okay. Now 27th. This we have done in the class, I think. If a ray of light is in a denser medium enters a rarer medium. Yeah, a denser medium, it is moving to rarer medium. So it bends density away from the normal. So it will bend like this. And they are told angle between reflected and refracted rays 90 degree. And this is R, this is I, this is R dash. Now we are asking critical angle. So we know sin IC for this pair is mu R by mu D. Right? But Snell's law, if you apply, what will get? Sin I by sin R dash, because that is the angle of refraction. Equal to I is in denser medium, R dash is in rarer medium. But mu R by mu D is sin IC. Now sin I by sin R. So R dash can be written as 90 minus R, because this is 90 degree. So R plus R dash will be 90 degree. So R is equal to 90 minus R dash, or R dash is equal to 90 minus R. So here I can write 90 minus R. So it becomes cos R. And above it is sin I. So I is equal to R because of angle of because of law of reflection. So sin I by cos R is tan R. So it will be IC is equal to sin inverse of tan R. Now a fish in water, refractive index n, looks at a bird vertically above in the air. This also we have done in class. Just take once again. A fish in water, refractive index n, looks at a bird vertically above in the air. If y is the height of the bird and x is the depth of the fish. So this is the fish in water, suppose. So this depth from the surface is x, and bird's height from the surface is y. So this is the bird. Yeah. Now distance of the bird as estimated by the fish. So for that, light ray from bird should come and hit the eye of fish. So if you see, this is rarer because it is air, and this is water, so this is denser. So when the light ray comes from rarer to denser, it bends towards the normal. So before coming to eye of the eyes, it bends like this. So if the fish extends this back, where you will get the image of the bird will be little above. So here the height of the bird as estimated by fish will be, this will be x plus this height, which is apparent height. And we know apparent height is, here apparent height is more than real height. So it is hr into n. So which is y into n. So the distance will be x plus ny. Then a diver at a depth of 12 meter in water, in fact 24/3, sees the sky in a cone of semi-vertical angle. So they have asked, this is TIR. So here is like this. and the diver is there at depth 12 meter. So now he can see only in this cone, right? Where I is equal to IC almost. Little greater than IC, but I is almost equal to IC. So this cone's semi-vertical angle is the cone angle, is a semi-vertical angle, which is equal to IC only because of alternate angles. So basically we have to find IC. And we know sin IC is equal to 1 by n. So 1 by 4 by 3. So it is 3 by 4. So it is sin inverse of 3 by 4. Sin inverse of 4 by 3 is not valid because sin theta cannot sin theta value cannot be greater than 1. Then two beams of red and violet colors are made to pass separately through a prism of A is equal to 60 degrees. The minimum deviation position, the angle of refraction inside the prism will be. So for minimum deviation condition, refracted ray will be parallel to the base of the prism and its value is A by 2. So if you see this R value doesn't depend on refractive index, because if color changes, refractive index may change because of change in lambda, but in R is independent of lambda here. So for both of them it will be 30 degree because R is equal to A by 2, IA is 60, A by 2 is 30. So I think only this much was there in CET. Yeah, okay. Any doubts you can ask later in the class. We'll stop it here.